Hi, I'm Peyton Gordon and I'm at El Camino Hospital, here to show you guys a interim loading dock that is currently being constructed by Rudolph and Sutton, a general contractor in California. The full scope of this project is the demolition of 2 buildings, but because one of the buildings is right above the hospital's loading dock, an interim loading dock is needed to be built in place of where the first demolished building was existing. The second building needing to be demolished is this brick building behind me, the elevator attached. Right below that is where the current loading dock is. The loading dock at the hospital is used for food deliveries, hospital supplies, really anything that this hospital needs to be able to function, because not all of it is shut down. It is still operational in some areas. This project started in October of 2021 and is scheduled to completely be finished in April of 2023. As for the construction of the interim loading dock, that's scheduled to be done this July. Here is the architectural floor plan of the interim loading dock. It will house a biohazard containment area, a trash compactor, and a loading dock speed lift. It will be covered by a metal canopy structure. Here is the foundation plan showing the foundation of each footing. There is a total of 18 footings supporting the columns. Each footing is approximately 3 feet by 3 feet and 1.5 feet deep. Here is a typical section view of each footing. As you can see, the base plate for each column is embedded into the footing. A blockout is left in the slab so that the columns can be bolted directly to the footing after the slab pour. Here is a close-up of the base plate detail. As you can see, there are 4 rods that were embedded into the footing, with a square plate that is approximately a 1/2 inch above the top of the footing. After the column is bolted down, the 1/2 inch gap will be grouted, and then each blockout will be infilled in a later pour. Here is a typical slab-on-grade detail which calls out the required reinforcing. This slab requires number 4 rebar at 18 inch on center in every direction. The slab is 5 inches thick with a 1 foot thick edge around the perimeter. It is installed over a layer of compacted gravel and a vapor barrier. In total, it takes 3 separate concrete pours to complete the slab. Before the construction of the interim loading dock could occur, the building that was standing in its place needed to be demolished. After the existing building was demolished, footings were excavated and poured with concrete. The 2x4s were framed in order to hold the embed bolts and plates at the correct elevation within the footings. Here, concrete is being poured into the footings. After the concrete was poured, the embed formwork was pulled out and the sonotubes were installed for the column blockouts. Here are water pipes that are for feeding the future loading dock. These are electrical conduits that will be used to bring power to the future loading dock. After the footings were installed, a vapor barrier was placed down and rebar was installed. Now that the rebar is finished, it's time to pour the concrete. Now we're back on site after the concrete's been poured and finished, and currently you can see walkouts for the columns to be installed for the canopy of the loading dock. In total, the concrete pour took about 9 hours. Unfortunately, it took a long time for it to dry because there was no use of additives, so crazy enough, the finish didn't get completed until around 1 a.m. Thank you so much for watching this video. I hope it was very informative, and we'd like to thank Project Manager Bradley Bondi from Rudolph and Sutton for letting us come on site and take a look at the construction process.